All right, so let's look at this question on momentum. So it's a combination, this question is a combination of conservation of energy and momentum. So anywhere where like energy is involved, kinetic energy, which is found in things that are in motion, right? Anything involving those things, conservation of energy is also, it is possible that conservation of energy is happening. And then anything that is moving, that is in motion, it is having momentum. So questions involving those situations, you need to be thinking of these two concepts. So let's read the question. The question is saying that, actually this question came in sessional. Okay, so the question is saying that a bullet of mass 15 grams and traveling at a speed of 600 meters per second strikes a block of mass 3 kg, which is suspended by a string of length 4 meters. The bullet goes through the block in a very short time, and the center of gravity of the block is found to rise a vertical distance of 10 centimeters, as shown in the figure 4.1. What is the speed of the bullet just after it emerges from the block? So we have a bullet. So this bullet, if you look at this situation, the bullet was like fired. Okay, look, in the question they have said what? There was it struck a block of mass, which is this mass. So when it was fired, it struck this block of mass 3 kg, which is it's suspended by this string that you're seeing. Okay, and they have said the length is what? 4 meters. The bullet goes through, it went through, it didn't get stuck in the block, but it passed through in a very short time. And okay, so like after it passed through, this block was then moved upward by the distance of this height that is found here. So you need to take a good look at these details. This height is very important. Okay, we need this in our calculation. The height which the block, look, in this question we're just having one block attached to a string. So we're just having one block attached to a string. This here, it is just showing what happened when the bullet struck the block. Then this is just showing that what happened now after the bullet passed through. So after the bullet passed through the block, that's when this happened. That's when it moved upwards by this height compared to the initial height where it was at. Here it is just at 0. Here there's no height, but after the bullet passed through, that's when there was some sort of height. That's when the block had to go at some height. It was now at a certain height. I'm repeating this because you need to understand, like, for this to make sense to you, you need to be seeing it like that. Okay, so let's now see how we can solve the question. So they're saying that, what is the speed of the bullet just after it emerges from the block? This is why the calculations now come into play. So initially the bullet had a speed, right, when it was just fired. Now after it emerged from the block, or after it passed through the block, speed changes. It has to change. It can reduce a little bit, yes, but there should be some sort of changes in the speed that it had after passing through. So that's what we are going to look for. Okay, so now let me show you the concepts that we are going to use to solve this question. And this question, when it comes, they usually bring it with 10 marks or 8 marks. So the first concept that you should be familiar with is the concept of conservation of energy, because it is the concept that we are going to use first. So the law of conservation of energy states that mechanical energy, initial mechanical energy is equal to the final, because final mechanical energy, because energy is neither destroyed nor created. Okay, so the initial mechanical energy should be equal to the final mechanical energy. Now recall that mechanical energy is equal to the sum of kinetic energy, right, plus the sum of potential energy. So this brings us to the statement that we can simplify this statement that right now I'm trying to show you where the concept is coming from. But for you guys who just want to memorize things, I'm going to show you the formula that you're going to master. Okay, on the first law. This is the law that you need to know how to apply on questions like this. So this is the first law of conservation of mechanical energy. Okay, so I'm going to show you the formula that you need to know, to be memorizing. Okay, so now this also means that the initial sum of chemical energy and potential energy, not chemical, the initial sum of kinetic energy and potential energy. I don't know if I said chemical. I don't know. Maybe I made a mistake, but this is kinetic energy. In case maybe I've said anywhere chemical, just pardon with me. I'm from teaching chemistry, so like the concepts are mixed in the head. Okay, so it should be equal to the final sum of kinetic energy and potential energy. Okay, now recall that kinetic energy is equal to 1/2 mv power 2. We even put I, meaning that this is presenting the initial speed, plus potential energy is equal to mgh, right? We put I, the initial height. Then we come here, we say 1/2 mv power 2. Then we put f, final velocity. Okay, then mg h we put f, meaning the final height. So this is the important formula now, okay, which we should know how to come with, how to memorize. We need to know how to come up with it. Now we simplify this a bit. Okay, okay, let me just end here, but when you start solving, I'll show you how we simplify this. So you need to know this formula. Then I think let's first apply this formula. Then we are going to use the second formula, which will come from the law of conservation of momentum. So let's apply this. Now let's go back to the diagram. We analyze it, show you how we are applying this. So here they're saying, what is the speed of the bullet just after it emerges? Okay, so what we're going to do right now is we're going to use this formula I've just written here. Remember, the goal is to find the speed of the bullet, right? But for us to solve this, we are going to begin by finding the speed that the block had. Look, so I'm saying that this block you're seeing right now, when you're using this formula, handling this question, our focus will be much on the block. Okay, only for this part where we're applying this law 1, law of conservation of energy. So look, we're going to find the energy, no, not the energy, the speed that this block had, the initial speed that it had the moment this bullet just emerged from it. The moment this passed through it, look, this initially it was at rest. In case you don't know, this question, whenever you see this question, always know that this one was at rest, meaning that it was just like this. It was not moving. So initially, this was not moving. But after this started emerging out, this entered in the motion. That's how it swinged here. Okay. Now, since it was in motion, meaning that it was moving at a certain velocity, right? Yes. So it had initial velocity that is it started the motion with. That's what we are looking for. So you're going to come to this formula. So okay, before I think okay, let me just proceed. So if you look here, this first portion, we are having what? We are having initial velocity, which is what we are looking for. Okay, we are looking for the velocity that it had when it was about to enter this motion from here to here, after the bullet emerged from it. Then when you look at this portion, there is height, initial height. Now, if you remember, I said always, whenever you see this question, we always assume that this was not at any height. In the question, they might not say that, but we always assume that this one was not at any height. It only became on a certain height after it swinged from here to here, which is the height given in the question. But before that, initially, it was just at zero height before it started moving with that initial velocity that we are looking for. It was at the height of 0. Okay, so I was saying that we always assume that there is some sort of height. I mean, the height here is 0. It only have a height when it moves. Okay, so now let's proceed. So this means that, with that being said, it means that here the height is going to be what? 0, right? Here the initial height is going to be 0, but the final height is going to be there because eventually it went at the height of 10. So the height is going to be there. Okay, so the height is going to be, but if we look at the final velocity, it is when it reached here at this point, right at the height of 10. So whenever you see this, it means that this was at its maximum height. It didn't go further. It just reached 10 centimeters and started coming back in a swing-like motion. Okay. Now, with that being said, since it couldn't go further, it means that the final velocity reached 0. Whenever any object reaches its maximum or its highest point or its maximum height, it always has the final velocity of 0. Okay. Yes, because it couldn't go any further. So like that was the end. But initially, velocity was there. Initial velocity is what moved it, is what ignited the motion from here to here. So now, with all this being explained, we can conclude that here we are going to put 0, okay? Because final velocity was 0. It reached its maximum point. And height, initially it was not at any height. The height was 0. So meaning that this will be out of the equation, because if I put 0 on H, the whole thing will be affected, right? If I put 0 at V, the whole thing will be affected. So the only thing that will remain in the equation is this initial velocity power 2 is equal to mg hf. Okay. So these are the things that we are going to work with. And this is, I think, the formula that we always use, the formula which I'm about to drive. I don't know, maybe they might tweak the questions, but that's why I'm showing you this. Like, I don't know, maybe how they can change the question. You know, this is physics. They can give maybe a question where maybe something is not 0. Maybe initially it might not be at at the height of 0. Maybe it can be at a certain height. So I want you to understand where the final formula comes from. There are some tutors who just give you the final formula, but it's not effective because questions maybe might change. Okay. All right. Now our goal is to find what? Initial velocity, right? So meaning that we need to make v this our subject of the formula. So first of all, let's multiply throughout by 2 so that we get rid of this 2 on the denominator. So here I'll just remain with mvi power 2 is equal to 2 mghf. Okay, and then we're going to, since m, actually this m, I've made a mistake. I was not supposed to write them like they are different. The m that we're having, it is the mass of the block. This mass is for one thing. I know in the question they'll give you mass of the bullet and mass of the block, but on this concept, our focus, like I said, it is on the block. So wherever you see any detail you're seeing here, it is for the block. And since mass for the block, which is similar, it is on this side and the other side, we can just cancel it out. So you're going to remain with this 2GHF. Now we introduce square root on both sides. So here we are going to remain with VI power 2 is equal to, no, power 2 actually will go when we introduce square roots on both sides. So we are going to just remain with VI. Makes sense, right? Then 2GHF. Okay. So this is the formula that we are going to use. Now, if you've observed, we are looking for the initial velocity of the block right after the bullet passed through it or emerged from it. I don't know the English, which will be easy for you. Yeah. Now, the block had mass, right? But if you look here, there's no m in the equation. Do you know what this means? It means that the initial velocity does not depend on the mass of the block. I'm just saying. Yes, that's just an observation. They won't ask you that, but if you are someone who loves physics, who want everything that they are doing to be making sense, so you can make sense out of this. Okay, now you know that the height, final height has been given to be 10 centimeters, right? Okay, so we need to convert this to meters. Listen, I always say this in physics. Every formula that you find in physics, it requires you to convert to standard units. If you've been watching my videos, I think I've been talking about that several times. So using dimensional analysis is the conversion factor that 1 meter is equal to 100 centimeters. So it is same as saying 10 divided by 100, right? That's going to be 0.1. Okay. So now you have 9.8. Then the final height is this one, which we've just converted, 0.1. So initial velocity. So if you punch this on a calculator, you're going to get 1.4 meters per second. Right. So we have just found the velocity which the block initially had before it moved to the height of 10. Okay. Or as it started moving at the height of 10, or the moment the bullet just passed through it. Now, in the question, our interest is to find, let me read the question again. What is the speed of the bullet just after it emerges from the block? Okay. Okay, so there is another thing I want to talk about. There are some questions whereby what I'm about to explain, make sure that if you are writing, write it down. So there are some questions whereby, have you seen the way they gave us that question? It was like this, something like this. Then it was looking like this, right? Now sometimes they might give you an angle here. Okay, they might give you an angle here. All right. So I was saying that sometimes they might not give you this height. This height they might not give you. This height is needed for us to do some calculations here. Now, usually what they'll do is that they'll give you an angle, but without giving you h. Then they'll give you either the length here or the length of this string, the distance from here to here. Let's call this A. So if you happen to be in this situation, use this formula. H is equal to L 1 minus cos theta. That's if the angle is also given. Or maybe they might ask you to find anything. Maybe they might ask you to find this. Yeah. Now this L is the length of this distance from here to here. Now what they like doing sometimes is that they won't give you this one. Instead, they will give you for this. And the height they won't give you. So if you ever happen to be in that situation, think of using Sokatoa. So just take note of this one. Just that I couldn't find a question where they asked something like this. Right. So let's proceed. So now we found this initial velocity. And I was saying that the question they want us to find what? The speed of the bullet just after it images from the block. So for us to do this, to find the final step now, which will give us the speed of the bullet, is that we are going to use the law of conservation of momentum. Law of conservation of momentum. So I want you to take note of what we've just found. This one. I'll come back to it. Right. So the second law that we're going to use is the law of conservation of momentum, which says that initial momentum is equal to the final momentum. In this situation, we have how many things which were in motion? When you reach on this step where you're using this concept, you are going to consider two things. Things which were in motion in the diagram. The bullet was in motion and the block was in motion. So we are going to be looking at the momentum of these two, where we'll be looking at their initial momentums and their final momentums. So since we have a bullet and a block, a bullet I'll be presenting it by small letter b, then the block I'll be presenting it by capital letter B. So applying the law of conservation of momentum, we are going to say that initial momentum for the bullet this is small letter b, right? I'll put I. The reason why I put I on V is because V, velocity changes, mass does not change, plus initial momentum for the block okay, VBF. So this is the final momentum for the bullet plus final momentum for the block. This equation is very important. Now let's analyze. Let us analyze. So if you look at the sketch that we had, let me, I think, just draw a quick one here. Just a quick one. Maybe it might not be perfect, but I just want to demonstrate. Okay, so I want us to look at the motions. If you read the question, what happened initially is what we are going to consider here. Look, this is momentum. We're looking at the collisions. So what is on the left side is what happened before the collision. The states of velocities for the block and the bullet before they collided. Then what is on the right side is the state of the velocities for the block and bullet after the collision. So let's start by looking at the bullet and the block. How they were initially. Let's start with the bullet, which is here. The bullet was already in motion. Initially, it was in motion, right? So velocity was there. We tick. Let's come to the bullet. The bullet. No, I mean for the block. The block. Initially, the block was at rest. Before it collided with the bullet, it was initially at rest. And anything at rest, it means that it is not moving, right? Since it is not moving when it is at rest, it means that velocity is 0, right? Now, I want you to pay much attention. Have you seen what I've done on this side? After the collision, the bullet and the block did not stick. Okay, they kind of like separated. They just passed through it. They didn't stick together permanently. No, that's why this side I've written it like this, because this is not perfectly inelastic. But if it was that situation, we would have done what we do. We would have just said open bracket MB plus MB for bullet and block times I'll show you like what we used to do on the formula for perfectly inelastic situation, where the two things eventually had to stick together. But since they separated, that's why we've written like this. Now, after they collided, was the bullet still in motion? Yes, right? It was still in motion. Was the block still in motion after they collided? Yes. And what is here? The final velocity of the block. This is the velocity which the block, actually this should be capital letter B. Yeah, so this is the final velocity. I mean, this is the velocity which the block had after the collision. This one. And this one is the velocity which the bullet had after the collision, which is what we are looking for. This is the velocity which the bullet had initially before it collided with the block, when it was just like fired. And this is given in the question. This is what we are looking for. Let me even put a question mark. This is what we found previously. If you remember previously, where we used the formula for conservation of energy, we were finding this one, the velocity which the block had after it collided with, which it had after the collision with what? With the bullet. That's what we're going to be putting here. I hope you understand. So with all this being said, let's now write the equation that you're going to use. So in the final equation you're going to use, we'll get rid of this because that object was, the block was initially at rest. So we are now going to have this. Okay, this question. Okay, so the mass for the bullet is given as what? 15 grams. We need to convert this one to what? We need to convert this one to kg, right? recall that 1 kg is equal to 1000 grams. So when you use dimensional analysis, you're going to end up with this 0.015. Okay. This is the what? This is the mass of the bullet. We've just converted it. In the question, this is given. It has been given for us. So we're going to put 0.015 times initial velocity, the velocity which the bullet had before the collision. And I think I'm going to show you a question where after the bullet struck the block, it did not pass through. It the two of them got stuck together, like it sticked inside the block. I'm going to show you the question. You see how you undo it. But the concept we are going to use is the same. So here, what are we going to do? We are going to put the velocity given in the question, which is 600. Is equal to mass of the bullet 0.015. This is what we are looking for. The mass after the velocity of the bullet after collision, right? Mass of the block in the question, this one has been given to be 3 times the velocity of the block after colliding with the bullet, or after the bullet passing through it, is what we found previously to be 1.4. Hope you are following. When you simplify this side, we are going to get 9. This side, here we're going to have 0.015 BF. When we multiply here, we're going to have 4.2, right? So now we're going to say 9 minus 4.2 is equal to 0.015. Like we've just taken this on the other side. For the bullet, so just divide through. So basically, this is going to be 4.8 over 0.015. That's going to be 320 meters per second. Okay. Right. This is what we are having. So this is the final answer now. This is the speed which the bullet had after it emerged from the block. Right. So there is this question. No, not this. Right. So this is the question. This is a different. It's the same question, but there's somewhere where it is different. Okay. So this one, they just asked it like this. They didn't sketch for you. That's why physics, I always say that try to visualize. When you see a question, try to form a picture in your head. So this one, they just gave you a statement. So for you guys who are lazy to think, you might say this question is tough, but this question is similar to what I'm just from solving, except just somewhere where I'm going to show you. Okay. So they're saying that a bullet of mass 20 grams is fired horizontally into a stationary wooden block of mass 1000 grams, suspended from a light extensible string of length 1.5 meters, forming a simple ballistic pendulum. The bullet embeds itself completely into the block, and the combined system swings upwards to the maximum vertical height of 0.45. Determine the initial speed of the bullet before the collision. So this question, a student gave it to me. I don't know where it came from, but she said from the test 2. Now I don't know which test 2. Yes. So one of the subscribed students sent me this question by the name of Trofina. I know all my students, even though you are a lot, I know each one of you. As long as you've texted me before, I know you. So Trofina, if you are watching this one, comment there in the comment section that sir, I've understood. Okay, so now let's solve the question. Okay, so let me now sketch the question. So they have said a bullet of mass 20 grams is fired horizontally into a stationary wooden block of mass 1000 grams suspended from a light inextensible string. So here there is some sort of this, which is what they are calling the inextensible string. When they say inextensible string, it means that, let me make it straight, the string cannot be extended even if you try to stretch it. If you try to pull it like this, or you hang something that is having a lot of mass, it won't extend, which is good for the experiment they were doing involving the simple pendulum. Okay, and there was this block of mass which they have given us. They have said the mass is 1000 grams. Okay, the mass. Now they are saying there was a bullet, right? So there is some sort of a bullet which was fired into it. So this is the bullet being initially fired into the wooden block, and it was fired horizontally. And what else have they said? So when it collided with the block, it formed what they are calling a simple ballistic pendulum, meaning that this one went into motion of a pendulum. Then they're saying the bullet embeds itself, meaning that the bullet did not pass through, it got stuck inside the block. This is like a bullet here. Okay, that's what they mean by saying embeds itself completely into the block, and the combined system swings. So listen, after these two, like after the bullet embedded itself in the block, after it got stuck in the block, it formed a system. Okay, it formed one thing, in short. That's why here they're saying that the combined system swings upwards to a maximum vertical height of, sorry, it swinged. So after it swinged, it came somewhere here. So I'll just I'm just trying to sketch. But you, when you're drawing, draw straight things, okay? Me, I'm using my free hand. And I'm not really an artistic person when it comes to draw. I don't know how to draw, guys. So that's like a bullet there, embedded. Okay? So even though it swinged, the bullet was still there, embedded. Now they're saying to a maximum vertical height of, at least this one, they have even specified that maximum height. This is how far it went. Of what? 0.45. Then they have said determine the initial speed of the block before the collision. Like we solved previously, just that here is different because the bullet did not pass through. And the only part where we do different things is on the formula for momentum. We will use the one for what's this? Perfectly inelastic, because they got stuck together. Okay, so let's use the law of conservation of energy. I think for this question, I won't really waste my time trying to drive. The previous question is where I did much of the teaching. That one I was teaching you. Now, since this one, I'm assuming that you've understood on the first question. If you won't understand here, go on the first question. That's where like I explained. Okay, I explained how to use the formulas. So I'll just write the formula which I showed on the first question, how to drive. Okay, when you apply what I taught you on law of conservation of energy, because the IT was 0, so you still end up with this. But I recommend that on your exam, just drive. I discourage you just coming up with this unless you are sure that they have repeated the same equation, whereby they haven't given you. I mean, they have said this one is not at any height, or in the question they haven't given you that this is at any height, because the moment they give you that this one was at a height, this block, I mean initially it was at a height, you are going to end up with a different formula. You only end up with this formula if this one is, I mean, if the height where this one was at is not given in the question, or if it is at h is equal to 0, that's when you end up with this formula. The moment you see that they have given you a height this time, the formula that you're going to end up with will be different. So just drive in that situation. But for you want to save your time from driving, now I think when lectures are marking, they want to see you driving this formula again. So I'm only not driving for the second question because I've already done that on the first question and I'm teaching you. But you on the exam, I recommend that you just at least show the stages. Do you know the good part of showing like you are driving the formula? Do you know the good part? Some of you who are not that accurate, if you get a wrong answer here, you won't get here some marks. You'll miss some marks. Now, if you've shown how you've like drived, you've shown the formula for conversion of energy, you'll get some marks, because by just showing that the initial sum of kinetic energy and potential energy is equal to the final sum of kinetic energy and potential energy. But by just showing that expression which I showed, you've already you're gaining some marks. Those are marks. Make sure that you write those stages. Me, I'm not writing because I've taught. Yes, you on your exam, show how you're going to come up with this. Okay, so gravity 9.8, right? Final height they have given us to be 0.45 meters. This will give us 8.82. So this is going to be for the block. It's going to be 2.92 meters per second. Right? Then now we use the law of conservation of momentum. Conservation of momentum. Don't expect me to write a perfect handwriting because I'm solving. This is not English. This is physics. This is not LA where you have to write things properly. Now, I'm not saying because I'm solving, that's why I'm doing this. You on your exam, write everything neatly. Even me, I'm neat when writing on the exam. And even though my handwriting is not that perfect, but on the exam, I make sure I perfect it. Just that in my videos, I try to be quick. That's why I write this doctor's handwriting. Okay. So now, the formula that you're going to use is this. When momentum is conserved, it means that initial momentum for the bullet times for the bullet plus initial momentum for the block is equal to, now we are going to do this. We are going to say MB, mass for the block plus mass for the bullet, times system, velocity of the system. This is what we are going to use. The reason why we are doing this is because after the collision, they didn't separate. They were stuck together. And the velocity of the system is what we've just found, because this is the velocity which the system had. The system at this velocity, which is the combination of the bullet and the block. This is the velocity we are looking for, the initial velocity of the bullet. Then initial velocity of the block will be 0, because the block was initially not in motion. Was initially not in any motion. Okay, so we are going to eventually remain with this is small letter. So mass of the bullet, or let me do this. Since I'm looking for this one, I'm going to make it the subject to the formula. I'm going to make velocity of the initial velocity of the bullet the subject to the formula. Bullet is small letter, so I'll have to divide through by mass of the bullet over mass of the bullet. So no, it should be small letter. This is the bullet. Let me do this again. Small letter b, its initial velocity is equal to mass of the block plus mass of the bullet times velocity of the system over mass of the bullet. Small letter b is presenting the bullet. Capital letter B is presenting the block. So now our job is to just substitute. Now, be very careful again. This question, they have given us something. What have they given us? They have given us the mass of there's a mass that is in grams. The mass of the bullet is in grams, so we have to convert it to kg. So it's going to be 20 grams times, because that 1 kg is equal to 1,000 grams, so it's going to be 0.02. So I'll do this. So I'll say block, mass of the block is let me check. Yeah, even mass of the block as well has been given in grams as 1,000 grams, which will give us 1 kg when we convert. So here I'll put 1 kg plus this is 1 kg plus 0.02 times the system. We found it to be 2.92 over mass of the block, mass of the bullet 0.02. So the initial velocity of the bullet when it was just fired is right. So this is all that I prepared for you today, and I hope that you have enjoyed this lesson. And if you're watching this from YouTube, make sure that you subscribe to the YouTube channel so that you can be receiving notifications whenever I upload this kind of a video. This kind of videos. And if you're somebody who's watching this and you haven't subscribed to our app, we have the app called the A Plus Academy app on Play Store. Search A Plus Academy app. So search for A Plus Academy app on Play Store. That's why you happen to access our video lessons, our pre-recorded video lessons. So we've recorded NS work from term 1 to term 2. Okay, they are organized videos which you can watch at your own pace, and we've showed everything that they ask on the exam. So what you've just learned in this video is just, I don't know if I should say 10% of what is on momentum. The rest has been taught on the A Plus Academy app. Okay, don't forget to subscribe, and if this video has taught you something, make sure that you comment in the comment section. All right, have a very nice day. Right, so if you want to access more of our simplified video lessons, come here on Play Store, then search A Plus Academy app. This app here, you can download this app. If you don't have it, then open it. Then after you do that, you're going to create an account and log in, and then on this app now you're going to find more lessons. So just come here on videos and go maybe on term 3. Let's say maybe you want videos for term 3. You can come here and click any term 3 topic. You're going to see all these videos, and in case maybe you want term 2 work for physics, you can come here and you'll see more videos for momentum and work energy and power. Like everything for A levels or NS work is already on the app. Okay, so make sure that you download the app. And it's not just physics, even these other courses like chemistry, mathematics, everything. These topics, the videos are already here, and physics and chemistry, all these topics, the videos are already here. So make sure that you download the app and subscribe.